The cities. Now let's get the elevations. And to get the elevation of each city, we take the list of random cities and feed it back into city data. So this was the list here of the 15 random cities. We did that on the last slide. See that here? Okay. And I'm going to feed this list into city data again to get the elevations of those 15 cities. And these are the elevations of 15 random cities. We don't even know. See, some of them are -1. I guess that's below sea level, one would expect. And we have some missing values for some of them. So we'll have to clean those out later. Now, what units are these numbers in? There's 250. What is that? 250 miles above sea level? So it's meters. 173 meters above sea level. So then I'm going to put them with the city name, which is this, and I'm going to list them out. So Halines is 70 meters above sea level, and Casagnes is 318 meters above sea level. And since this is random, I'm going to pick 15 random ones again, along with their meters above sea level, or meters relative to sea level. So this is what we want. We have the whole thing, basically, except it doesn't look like a report. This is actually what we want, but it doesn't look like a report. So I'm going to use table form to make it look more like a report. And so obviously this looks kind of like a report. I'll do it a few more times and do some randomness tests. I don't know these cities. They could be names of bread. If I had a French person helping me, then they would be able to help me verify that these are cities, but I have some confidence that they are. At least the names look French. And these elevations look reasonable. Again, I don't know for sure if they are exactly correct, but they're in our curated data database. Now we need to clean out some of the data. You saw the missing. So what we're going to do is use something called select. And select will select the ones where missing does not appear, is free of it. These items are free of a missing value, and obviously this could reduce the number to less than 15. So let's run this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So one of them had a missing this random time. So I'll run that a few times. We're getting lots of cities here. Now this is less, but still random, so let's put that in the table so it looks like a report. So now we shouldn't see any missing ones, although there may be less than 15 in certain cases. So we got rid of all the missing ones. We cleaned the data out. Now let's get some help from Wolfram Alpha. So I have a little application that lists out 15 random French cities from a list of 36,000 cities and shows their elevations. Cities without a supplied elevation are filtered. That's the missing ones. Now I want to see what Wolfram Alpha knows about those 15 or so cities. To do this, I wrap an href anchor, href being an HTML tag thingy, around the first column or the first entry. So let's take a look at how that's done. Right here, we take our same select that gets rid of all the missings, and before that we wrap it in a Wolfram Alpha command, and then we map it against our previous list. So let's try this, see if it works. And we, oh, I'm sorry, I took out, oh, okay. This actually doesn't show the elevations. We only wanted the names to be hot. So let's run it again. And just to test it out, I'll take some name, Long Souls. And I'll click on it. And it'll throw me over here to Wolfram Alpha. Oh, I didn't like that. How about that? Let's try another one. Look, it liked this actually. It's in France. There's 396 people. Its elevation is 335 feet. It's 41 degrees Fahrenheit there. It's a little bit chilly. So what we've done is we've wrapped this hyperlink thing around this. Check the help browser. Looks pretty easy how to do the Wolfram Earl syntax. So I'll take the first item of each entry. This is the first item. And you convert it into a hyperlink using this type of href. So that wasn't too bad. And then we forgot the elevations, so let's bring the elevations back. Here are the elevations. And as you can see, we have a list of, it's not table formatted, but here's another city. Its elevation is 288. If I check it back over here, Alpha does think it's a city. Oh, look, the elevation's different. That's interesting. And it's 43 degrees there. And here's some nearby cities. So we're getting pretty close here. We make the final report with the elevations in the Wolfram Alpha hooks in a table. And there it is, and we can run it over and over. And this is basically how the original application was made. So let's see here. So here's our wrap up. So the steps we covered were the background and impetus for this whole thing. We reviewed the original sample application. We showed and explained the code to attract the data from Mathematica and clean it out. And we explained how to hook this to Wolfram Alpha. Are there any questions?